Okay, this is the first of three types of problems that we could see. So this is an example of a calorimeter problem because we've got fructose. So we've got this type of sugar and it's burned in a calorimeter. So I know that this is a calorimeter problem, states it directly in the question. Given these two equations that we've learned, I know that enthalpy of a reaction equals number of moles times molar enthalpy of the reactant. Also, I know that energy, Q, is equal to mc delta T. So given these two equations, we can put them together to make up the situation for a calorimeter. So I know that delta H of my system, which means these are my reactants. This is what's happening. This is the chemical reaction, is equal to Q of the calorimeter. So if I know these two pieces are equal to each other, whatever energy is gained or lost by the system is going to be absorbed by the surroundings, which is the calorimeter. So system equals surroundings. If we sub that in, I get N delta RHM for the enthalpy of the system is equal to MC delta T, which is Q of the calorimeter. So let's sub in the information that we know. So for the left side, this information applies to the chemicals that are reacting. Okay, the water in the calorimeter is the values that we use on this side. So my reactant in this case is fructose, and the amount is already given in moles. Now it's given in millimoles, so what we could do is just convert that to moles right from the start. Or you could convert at the end. I'm going to convert to moles right away. So this will be 0.0015 moles of fructose. And what we're solving for is the molar enthalpy of combustion. So this value here, the molar enthalpy, is what I'm solving for, specifically for combustion. And this is going to be equal to mc delta T of the calorimeter. So this M is the mass of the water. We never ever sub in a mass of a reactant on this side. We always use the water in the calorimeter. Remember that if you want your units to end up as kilojoules, then we have to use kilograms as our mass. You can convert at the end or you can convert now. So I find it easier if we just convert to kilograms. My C value then will be 4.19 kilojoules per kilogram degree Celsius. This way, my kilograms will cancel. Now I just need to cancel out degrees Celsius by multiplying the temperature change, which it says it increases by 3.85. So delta T, change in temperature, is 3.85 degrees Celsius. If I just write that over 1, degrees Celsius cancels out and it leaves me with kilojoules. I want my answer to be in kilojoules per mole. So once I simplify this, I'm going to divide it by 0.0015 moles so that I can cancel this out over here and we can isolate the molar enthalpy of combustion. So I get a molar enthalpy of combustion equal to 2,688.58. If we put this in scientific notation, we'll move it 3 spaces over, and this 8 will round up to a 9. So I get 2.69. The units are kilojoules over moles. And it's going to be negative because this is an exothermic reaction. So this will be negative 2.69 times 10 to the 3 kilojoules per mole. So our answer here would be